All right. So number 5 is just addition. So did they really need the parentheses around anything? No, because in front of those parentheses are both positive 1. It won't change anything inside. So they just put the parentheses, say this is one polynomial added to another polynomial. You take the parentheses out because when you distribute 1, everything stays the same. So what can I combine?
7A4.
Yeah, 7A4 and 4A4 makes 11A4. And then anybody go with this guy?
Minus 4A.
Good. Negative 3A cubed, negative 1A cubed, negative 4A cubed. That's crazy. And then this guy,
Minus A2.
does he have anybody? And this guy, does he have anybody?
No.
Shoot. So it's minus A squared plus A.
Yeah.
And technically it doesn't really matter how you ordered it, but why do you think I did it like that? So the powers are all descending. 4, 3, 2, 1. Earth below. Sorry. So very often we want to put answers, polynomial answers, in descending power order. So what about number 6? What's the very first thing you should do?
Put the like next to it.
Nope, can't do that yet. Distribute the negative. So I'm subtracting all of these. So I have to distribute. So really when I distribute a negative, it just changes all the signs.
Do you just can't you just change the subtraction sign to addition and then change all the signs?
Yeah, exactly. I mean, however you want to show it to yourself. So just to be real clear, I'm going to rewrite it. So minus a negative is plus. Minus a negative is plus. Minus a positive is minus. So everything in that second dude changed sign. Why did nothing in the first dude change sign? Because there's just a positive 1 in front. It's not going to change anybody. But that minus always trips people up. Got to be careful. Got to distribute that bad boy. And now I look for like terms. What's the highest power here? Cubes, right? So anybody go with that guy? Yeah. So what do you get there? Let me see where I can put this. 6x cubed. Squares. This guy and this guy. So I get 7x squared. And then I got first power of x. Minus 7x. Minus 8x. Minus 15x. Cool. So, personally, I don't like to... You could rewrite the whole thing and put your x cubes together, put your x squares together, put your x's together. I like to use different shaped underlines to kind of visually put things together. Do you guys see it? But whatever works for you. All right. Oops, sorry. So here's the answer. And... number 7 is the exact same kind of problem. The only thing they've done to me in number 7 is fractions. Now, for some reason, people suddenly think, oh, I don't have to get a like denominator because we're not in that section. Fractions, you have to get LCD if you want to add them. So what's the very first thing I should do in number 7? We'll do this one together. Distribute the negative just like we just did. So I get 1/5 x cubed minus 2x minus 3/7 plus 2/15 x cubed minus 2x plus 1/7. So the x cubes, before I can put those together, what do I have to do? Yeah, so he needs 3. I like it. So it becomes 3 over 15. So 3/15 plus 2/15 is 5/15, and then I can reduce that on the next step. You guys see that? It's not a big deal, but when you want to combine like terms, you want to combine your x cubed terms, and if they have fractions in front, you have to get like denominators for those fractions. They can't go together otherwise. Let's see. And then the x's is nice. Minus 2x, minus 2x. Negative 4x. Careful. They only cancel if they're opposite signs. And then this is nice. Minus 3/7 plus 1/7 is minus 2/7. Cool. And then the only thing I got left to do is to reduce this to 1/3. Just because it happened to come out to 5/15, so I can reduce it. All right, maybe. So it's not a different problem just because they put fractions in it. It's just a little bit harder because you got to get LCD to put your like terms together. I like it. So let's see, the last thing we'll talk about today. Well, second to last thing. Sorry. You should expect this kind of thing. Polynomials are just asking for this. Polynomials can have multiple variables. So one thing we do in algebra when we have an expression with all these variables is what happens when you let them be certain numbers. So this should be nothing huge. This should be nice. So if they let x be 2 and number 1, what do? Yeah, just put a 2 in for x. So I get 2 times 2 squared plus 5 times 2 plus 1. And then I just have to evaluate that. So this is old time. This is old news. We've done this kind of thing before. Number 2, you get 2 variables, so they let me know what both x and y are. You just plug them in and go to town. Yes, ma'am?
Which one would you multiply by first, the exponent or?
Oh, so when I plug it in, I haven't done anything, right? So, and I try to preserve the operation, so I put them in parentheses. See if the 2 is in parentheses. Now you attack it. What do you do first, exponents or multiplication? Please excuse. Yeah. Order operations never goes away. It never. It's not. Doesn't have its own section. It's just there. Yeah.
What page is that on?
Oh, 89. So this would be 2 times 4 plus 10 plus 1, 8 plus 11, 19. All right. Square the 2 and then multiply by the other 2. Cool. Alright, so here's the last thing I want to talk about. Multiplying polynomials. So this one is old news. Multiplying monomials, we already did that. It's nothing new. The new thing is going to be, not even the next step is new. So these 2 are old. I'm not saying they're easy, necessarily, if it's been a while for you, but they're stuff that we already talked about, right? How would you do this first one? Yeah, 10 times 5. P to the. Careful. Yeah, you got to remind yourself. You got to do it. Yeah, 10 times 5 is 50.
P5.
Add the powers. Yeah. You add when you multiply. So a while back I was tutoring some cheerleader and she came up with the whole thing. And the only thing I remember is when you multiply, you add. Right. X makes it look like a plus sign. So when you multiply things like bases, you add the powers. I don't know if it's going to help anybody at all. You're like, what the hell is he doing up there? But that's just something that stuck in my brain. She had other things for other than, like, I can't remember shit. That one thing really stuck in my brain. So this guy, same way. You can you can multiply the numbers, so that becomes negative 6. It's crazy. How many x's do I have now? 5 of them. How many y's do I have now? 5 of them. Cool. So what degree is this term? 10th degree, kick ass. He's like, don't do that to me. Now, all right, is that decent? I mean, we've already done that earlier. We did that back in section 5.1, a million years ago, or maybe like half an hour. This is nothing new either. What are all of these? What property are all of these? I mean, well, it's telling distributive properties, nothing new. So where's the new stuff, Jeff? Well, here's the new stuff. Here's the sort of new stuff. And I hate that we make it sound, I personally, this is not that terrible, but I wish you never were taught that. And let me tell you why, because some of you guys love it, and you use it. Sure, use it. But it's so desperately unnecessary. And I want you to really understand why. If I had x times x plus 4, I would take the x and I would distribute it, right? Isn't that how I would do it? Yeah. So I get x squared plus 4x. So how many things are there in front of x plus 4? How many things are sitting in front of x plus 4? An x and a 3, right? X plus 3. So the x gets a turn. Distribute the x. What do you get? X times x. X squared. X times 4. And then the 3 gets a turn, or else it wouldn't be fair. 3 times x. 3 times 4. I didn't have to say FOIL at all. Right? I just distributed each piece. So where's FOIL come from? The first 2, the outer 2. the inner two, and the last two. And to be honest, that makes it sound more complicated. To me, I don't know. So if you love FOIL, kick ass. But here's the real reason why FOIL sucks. Let me go down here. Miss Maroon. What if I had this? So just to be a complete dork, and I'm used to it. Well, it's not FOIL anymore. It'd be like or something. Because now you got like first, middle, last, middle. I mean, you got more letters. No, screw that. So what's a better idea? Just keep doing the same thing. The X gets distributed, bam, 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 and then the 2 gets distributed, bam, bam, bam. And then if you just realize that it doesn't matter how many pieces I put into each. Each one of these just gets its own turn, and then you put like terms together. So try that one. Try that one I just made up. Let's see how it comes out. Alright, so when we catch up to you, when I take the x through, so the x gets a turn first. X times x squared is x cubed. X times negative 4x
Minus 4x2
minus 4x squared.
plus 7.
Wait a second, let me stop there for a second. Is that cool?
Yeah.
Alright. And then x times 7.
Yeah. Plus 7.
That's great.
No, this one's too.
What's up? What's that I missed? I haven't done any with the 2 yet, right? I'm not done yet. That's the x. Now the 2 gets a turn.
Plus.
So now I can do, and if you're nice to yourself, you can actually line up your like terms. Plus 2x squared. What's 2 times negative 4x?
Minus 8.
Minus 8x. And what's 2 times 7?
Plus 14.
So now I got x cubed's got nobody. Aw. Minus 4x squared plus 2x squared is
Minus 2x2.
minus 2x squared. 7x minus 8x.
Minus 1x.
Minus x, kick ass. And then 14's got nobody, so it's just a 14. Bam! So you guys see, now it doesn't matter. If I put 5 terms in this one and 8 terms in that one, you'll go, what the hell, Jeff? But you can do it. You just, each thing gets a turn, and then you get your like terms. I'm not going to do that because that would be busy work. But that's why I don't like FOIL, because it just makes it seem like it's its own thing. It's not. All right. That's plenty. Oh, my battery.